Sound test 1, 2, 3, and 4. Stream will start soon. Why doesn't it load in Codeforces? Hi Shihab. Strange. Maybe link is incorrect? No, it's correct. Right, we're doing harder problems today, Division 1 problems, starting with this one, token removing. Hi, just give up. I'm not going to read your full nickname. Hi, Akash. So, still nothing? Strange. Raja, Zikrus, Shabu, welcome. Please solve some 2000 rated problems today. I think I'm going to. Or do you mean that you want at least that difficulty or at most that difficulty? Or exactly 2000? Start time? Oh, in UTC. Strange. Well, so yesterday's contest, not the full contest, but if you think there are some particularly nice problems. Yeah, I don't know what is up with this. Okay, so the token removing problem. Why is it not saved? At least 2000, I see. C and D were nice. Okay. Still, I promise to first solve this. We'll see, we'll see. Also, I have some small update. I decided what classes I will do next month. If you're interested in that, you might consider it. It's not published yet, but in August, I want to do 2 groups of paid classes, both about dynamic programming. One will be easy group about problem solving, so that you'd be able to solve every easy problem. And this is a group for people who only know how to solve few of easy problems already, and they struggle with them. And second group will be about harder techniques, like broken profile, divide and conquer DP, stuff like that. Yeah, so this is the plan, I think. And there will be Sunday evening lead code classes. So that's some update about that. Like every stream I'm mentioning a little bit about it, because every stream I have decided something new about it. Okay, token removing. The task said that there is a sequence. We consider a sequence with numbers that satisfy some inequality, and there is a process described. At the end, we care about the number of remaining tokens. We want to sum up that value over all the possible sequences of length n. And what was m? Oh, module. Okay, and what else is there? Yeah, I will just draw it. Is it a free class? No, it will be. This thing will be a paid class, 200 something euro, 250 euro for that month of classes twice a week. Mm. Okay. Just making sure everything works. Number of ways to remove tokens. Oh, yeah, Zikros, you're right. I would... This is how I remember that, so this is what I would explain in the drawing anyway. Do you plan to start doing Codeforces contests regularly? Not regularly, but I hope to do it from time to time. Now, a drawing. So this is what we have. We think about a sequence of numbers from 0 to n, or actually from 1 to n. At every number there is a token. Maybe let's do it from 1. At every number from 1 to n there is a green token initially. And in order from 1 to n, what happens is we're given some range. This range is from ai to I. So the range always ends at every new position, position 3, position 4, 5, 6, 7, and so on. And we are given its start as element of the sequence. We can eat or kill some token inside of this range. At the end, we care about the number of ways to remove tokens. So if we start with, let's say, this blue range, we have 3 ways to eat a token. Then we have the yellow range. We have 1 or 2 ways, depending on whether the blue token already ate a token, or blue range, whether it ate this one or not, the third token. The question is, given a sequence, how many ways there are to do a sequence of moves? And then we want to sum this up over all sequences. Can I start competitive programming at 32? Yes, of course you can. But if you're not already good at math and programming, you will have a hard time. But if you treat it as a hobby, just like you would do, I don't know, Sudoku, then sure. Just treat it as a hobby, not as something where you need to excel at and be the best in the world. Okay. Given a sequence, can we compute the answer? No, I'm not vegetarian. Why don't I use X over Y? Sale, why should I use what you're saying? To be honest, I don't even know what that is. Tiling WM. Okay. Also, numbers can be 0, but let's say they are not. If a of 1 is 1, then we always eat token 1. If a of 2 is 1, then we eat token 2. If a of 2 is 2, we also eat token 2 because that's the only one available. Something else happens if a of 1 is 0, then eat nothing. Then a of 2 is 1, then we would eat 1 or 2. If a of 2 is 2, then we eat 2. Depending on, also a of 2 can be 0. Depending on which of those two options happens, then for a3, for example, equal 1, then that's always two ways. So what this means is I want to eat a token from range of 1 to 3. There are always two ways because always some token is eaten. But if we have this, so we eat something among tokens 2 or 3, then it depends. It depends on what happened in the previous step. And it seems to me that it's very important how many times we ate nothing so far. So I'm guessing that in some way this will be dp of position and number of nothings so far, or equivalently number of tokens we ate. Your Jane Street t-shirt I love. Do I have it on me? This is an ICPC t-shirt, and I don't see Jane Street logo. Maybe I just don't see it. Or are we talking about a different one? Quant finance via competitive programming? I think so. I think you can do it. But I'm not an expert there. So this thing, it can always eat a 3. It can sometimes eat a 2. It can sometimes eat a 1. After this problem, I will. You were wearing that yesterday. Oh, the yellow one. Is it from Jane Street? If you say so. But I'm not sure if maybe it's from JetBrains. I'm not sure. Okay, from Jane Street. Got it. So the yellow one. Actually, I almost wear it again today. Every morning I go for a walk with my dog, and I actually wear a t-shirt from yesterday. Just after that I get a shower. And I didn't have much time today in the morning, so you would almost see me twice in a row in the same t-shirt. Probability to solve problems declined? Yes, I think so. I don't practice that much. In particular, so I think that I was, for example, extremely good at geometry, handling precision errors, stuff like that. I would not make any bugs, and now I'm way worse at geometry. Let's say that we have a range of size 1, then size 2 is skipped, size 3 is skipped, then for the size 4 we have something like this, let's say. Then for size 5, by size 5 I mean a range ending with a 5, we can have few possibilities. So we can have this range, we can have this range, this one, this one, this one. And actually here the one is always eaten, so there is no difference between those two. This one is most complicated because depending on our choice here, something else happened. This statement of summing up possible ways is equivalent to counting the number of sequences of pairs. Count sequences of pairs of the AI, comma, the actual token that you eat. Let's say token of I. This means in the if move, which token you eat. The statement could just say count the number of such sequences of n pairs. So it seems that instead maybe I will focus on in every operation which token is eaten, and then I will sum up the number of ways to choose AIs. So I will not think about ranges too much. Instead, what I'm going to do is say, for example, maybe in the first move I'm eating this token, in second move I eat nothing, in third move I eat nothing, so like token 0. In fourth move I can eat one of those 4, and for each of those, like maybe this is what I eat in the fourth move. If so, I multiply the answer by 3, because this is the number of places where the range could start. So here, because of this guy, I multiply the answer by times 1. This one I multiply by times 3. Then there is then for the fifth move, I eat some token. Maybe it's, for example, this one, or maybe this one. If I go with that one, I multiply the answer by times 4. So the statement said, among all the sequences of ranges, sum up the number of ways you can choose which tokens to eat. And instead I'm doing, over all the sequences of which tokens I eat, sum up the number of possible sequences of ranges. I will go back to answering questions later. Also, was Codeforces finally fixed in terms of this? Still nothing? Do you see my stream when you... Oh, now I see it. I mean, it's loading. It's loading. Okay, works now. So this, it seems that no matter when I eat this token, the answer will be multiplied by times 4. So I can alternatively say that at any moment I eat those few tokens, then there are 12 ways to choose where the corresponding ranges start. And there is another question of those tokens are assigned to what moments. So maybe we will do DP going from left to right. So not by time, not by the index from the problem statement. Instead, I will go this way. And for every token, the first one, second, third, and so on, I will decide if I ever eat it or not. Depending on that, the answer will multiply by this. And additionally, I need to keep track of how many ways there are to assign this to some moment of time, which means, and there are always that many ways to do it. So I think we will go from right to left, because if this token is assigned to some moment, so this is token number 4, it's eaten in the moment from 4 onward, but it's eaten by one of them. Then for this token number 3, it's eaten at moment one of those, except for the one that this one chose already. Right, so this one has some suffix size and we multiply it. This one has some suffix size and we multiply by it -1 because of this guy. And I need to know how many other tokens are already eaten. So I'm going to, I think, I'm like a little bit more than 50% sure about the correctness of what I'm doing. With DP, we iterate tokens from n to 1. This is not the index from the statement, this is the token position on this axis. For every token, decide if it should be eaten. If so, multiply the answer, the DP value, by, this is prefix size, multiplied by suffix size, minus number of previously eaten tokens. I think this is what we do. This will be a DP dimension. This is very easy to implement, so sometimes after coming up with such an idea, I would analyze the samples to figure out if it makes sense. Maybe I want to analyze this n equals 2. Yeah, let's do it before I implement. But if the code is short enough, sometimes in a contest I would not even look at samples, I would just code it in 5 minutes and that's it. But here also for educational purposes, let's try to, or for you to understand my idea better. If there are just 2 tokens and I'm looking at, initially DP of 0 is 1. This is number of ways to eat 0 tokens. Then I'm looking at token 2. I assume n equals 2. I can eat it or not. If I eat it, I will multiply the answer by 2. So I think this was what will happen. This is prefix size, this is suffix size. Right? So for this token, prefix is of size 2, suffix is of size 1. Then when I look at token 1, now dp of 1 plus equal dp of 0 times 1 times 2, this is now prefix and suffix the other way around, but additionally dp of 2 plus equal dp of 1 times, I think 1 times 1, or this is prefix size and this is suffix minus 1 already eaten token. So what do I have from this? I have dp of 1 is 2. From this I have dp of 2 is just increased by 2. And after that I'm doing this operation, obviously. dp of 1, it was 2 and plus another 2, it's a 4. So now I have 1 plus 2 plus 4, it seems. That's a 7. Works. Let's code it. I think it's a quite nice problem. Not very easy to explain. Like if you don't feel the solution, it's very hard to get to understand it. After I'm done coding, if I get accepted, I will explain again. So we move backwards. Some kind of, well, where token is. And always I decide to eat this token or not. I iterate the number of tokens already eaten. Better do it decreasingly. And I decide to eat it or not. Eaten plus 1 plus equal dp of, I will add modulo in a moment, dp of eaten times, if I decide to eat this token, I multiply by the prefix size, which is this, and the suffix size, which is, I think, that, minus the number of already eaten. Also sanity check, so like a check that makes sure or helps me checking if the plus minus 1 is okay. Eaten is n minus token at most, so n minus token minus eaten will be 0 at least, so this will be at least 1. Makes sense. Also dp of eaten, well, doesn't change. I can decide not to eat it, so it's just this. At the end, print the sum. I will add modulo in a moment. Seven 37 273. Great. Now modulo. This is not the most efficient way of applying modulo, but I don't care that much about the runtime. Doesn't work. It worked. Wait. I'm doing something stupid. Oh, my answers are shifted by 1. Why is that? So it seems that for 1 the answer is 2. I'm tempted to just do n++ or something, or n-. How many problems have I solved till today? In my life? 3,000? They update DP1 after updating DP2. Because of the order they affect each other here. So this is how you... I didn't explain it, but I wanted to save memory. I didn't want n² memory, even though maybe it would be okay here. What happens here is when DP2 affects DP3 and DP1 affects DP2 at the same time, like simultaneously, you need to do them in this order. If you first did this, then DP2 would already be modified, even though you should simultaneously consider that. When you consider token n, simultaneously you need to update all the DP states. So without having a second DP array or an extra dimension, this is the order that you need to do it. This order does not matter if you have an extra dimension. That being said, also this is not, even though the code is short, this is a hard DP problem to come up with. So it's not a good one for you to learn about tricks like this. What is the level of this problem? I don't know, 2000? It's to avoid saving the eaten dimension. It's to avoid having a full DP of position and eaten. I erased this dimension and I just have DP of eaten. Okay, why is this? In particular, I analyzed what will happen for n equals 2. And my program does not agree. Am I tripping, or did I see this video before? Did you also see your comment inside of the video? Yesterday we started solving this problem, but I said after a few minutes that I'm leaving this for a division 1 stream. So for the harder stream. AI will surprise humans in problem solving? Yes. Okay. I mean, so during a contest, I think what I would do here is I would do this. Run. It's correct. Submit. But I do not understand why would I need to do it. I want to understand before submitting. So I just see that my answers a moment ago were shifted by 1 compared to the correct ones. I think maybe I want to print some debugs. Hmm. Maybe just run 1,2,000. Token 1 did not do anything. How is that possible? The prefix size is token, not token -1. But why would this work at all? Oh, I think I see why. We have one empty iteration where this is 0. Oh, so simply the token equal to 1 does not do anything. We only iterate from n to n, from n to 2 basically. Suffix size is not affected. The prefix size I decreased by 1. Okay, the last iteration is empty. Now I understand. For you, it's not that important to understand my mistake. It's just stupid typo / mistake. If you're at position 5, the prefix size up to it is 5, not 4. Now I can submit and I can explain again. Also, I'll look at the editorial. Calculating the weight of a single valid sequence is difficult. This is what I thought, that this might actually be easier when we sum up over everything. Well, not obviously. Okay, this is a bad editorial. Okay, accepted. Now, let's talk about this. I will for a moment hide my camera. Well, not necessarily. So the full solution to the token removing. The task asks us for something quite complicated / convoluted. What happens here is we have positions from 1 to n. So 1, 2, 3, 4, and so on, n. And we consider some sequence that defines ranges to us. Always, every next range, it ends at the next index. So first range needs to end at 1, second range needs to end at 2, third range needs to end at 3. The start can be anywhere on the left. Fourth range ends at 4, and so on. Some ranges are skipped. For example, there might be no range ending with 5, or maybe no range ending at 3. But then maybe there is range ending at 5, maybe not. So for every position, there is a range ending there, one range, or maybe there is no such range at all. Now, in order of those ranges from left to right, so ending with 1, 2, and so on, we will eat a token inside of a range. And that will always be possible, because initially we say that there is a token at every position from 1 to n. So first we look at this blue range from 1 to n, and we eat any token inside. That must be this token. Then we look at the second range from 2 to 2, and we eat any remaining token inside. That would be this one. Then the range ending with 3 is skipped. Then we look at a range ending with 4, and we see that we have actually 2 possibilities of which token to eat or remove. So we have 2 ways to do it. We remove one of them, and depending on that, we can have different number of ways to continue in the future with future ranges. And the task is, among all possible sequences of ranges, in the statement they are defined by the sequence A, which is not in the input. We consider all possible sequences A, sum up the number of ways to eat tokens. So a sequence saying in every move, which token do you eat? Now I'm going to write this in equivalent way. Among all possible sequences of tokens to eat, sum up the number of possible sequences of ranges. This is, well, same thing. In both cases, like, let's say one number of ways gets multiplied by the other number of ways. So we work with this. And when you know that some token is eaten, so among the tokens, when you know that, let's say, this token is eaten, the token number 3, where could a range start? Well, the blue range needed to start at this position or this position or this one. If it starts in any of those, it has a chance of containing this green token at position 3. Where can it end? Well, at this position, this one, and so on. So roughly, the number of possible ranges that start on the left and go to the right is equal to the prefix size multiplied by suffix size. So that's token index multiplied by n+1 minus token index. This is the formula, roughly. But there is one more thing. The statement defined that the ranges can start anywhere on the left as long as the start point is to the left of endpoint, or exactly at the same spot, but the endpoints are distinct. If there is a range ending with 4, there cannot be another range ending with 4. So what I'm going to do here is say, well, yeah, if there's such a token, the number of possible endpoints here is suffix minus, maybe I will get back to this simpler format, prefix times suffix. It's suffix minus the number of already decided ranges that end to the right. Decided endpoints on the right. So here, because maybe here in the suffix we already decided there are some 2 ranges that end there. Then the number of ways for me to choose the endpoint now is suffix minus 2. If we go now from left to right, deciding what to do with tokens and multiplying the answer by such product, so here again, minus decided endpoints. If we go from left to right, we will not be able to know by what to multiply, because if we know that for some token we decided a range that starts here and ends somewhere to the right, maybe here, maybe here, maybe here, then for some token in the future, like a token here, we will not know if earlier we decided that the endpoint is to the left or to the right. Going from left to right, we have no way of keeping in just a single dimension of DP information about where exactly the endpoints ended, so that for the following tokens we would know how many available endpoints are to the right. But this is viable if we go from right to left, because if for a token you have any range that contains it, so it might be this range, it might be this range, it might be this range. If you have any range, you know that for the next token, so for this token, if you know that there is some blue range, then for all future tokens on the left, for example for this one, or for this one, or for this one, for each of those, you know that one endpoint on the right is excluded. So then the decided endpoints turns into just number of ranges used or number of eaten tokens, going from right to left. So the token iterates from n downwards to 1, decreasingly. That's important. It will not work the other way around. At least I don't think so. So the code is that we do DP, and we need to know the number of eaten tokens, so this will be a DP dimension. We go from right to left, and we have something like DP of position, or the token, and number of eaten already. We start by saying, let's say DP of n or n+1 with 0 eaten is 1. There is one way to be at token n+1, or to be at token n, with 0 eaten tokens. In my code, you will not see this dimension because it's very common to skip the first dimension, the one about index, to save memory and thus improve the runtime a little bit. So I just have this, but I start from token n and I go decreasingly. And to look at my code again, the code is obviously very short, like it's usually the case with DPs. We start by saying dp of 0 tokens eaten is 1, there is one way. Iterate tokens decreasingly. Iterate the number of eaten tokens so far. And we do it decreasingly here because the transition here is like that. So if you did it increasingly, then, for example, dp of 3 would affect dp of 4, and after that dp of 4 would affect dp of 5, and so on. So dp of 3 would immediately affect dp of 5. This would be equivalent to allowing us to eat multiple tokens at the same position. As affecting from this dp immediately, looking at a single token, it would mean that we pretend that we eat 2 tokens here, because number of eaten jumps from 3 up to 5. That's not allowed. Hence, I do this decreasingly, and this would not matter if I went with 2-dimensional dp. And the transition is that from dp of eaten, I transition to dp of eaten plus 1, and I multiply by the prefix size times the suffix size minus eaten already. I mentioned something about the modulo operations not being efficient here. Actually, I do here 3 modulo operations, while you could do it with 2, maybe even 1, which would be a little bit faster. Does not matter. In some problems where you really optimize for runtime, you should avoid many modulo operations because they are slow. Hello, Ronaldo. Okay, and I think that the editorial in this task is bad. So I now understand why people yesterday suggested this problem and said that they do not understand it. Maybe I will cut this part of the stream and put it separately on YouTube and link in the editorial or something. We'll see. Any questions? New person in competitive programming, made an account 4 days ago. I was wondering what are the best tips you could give so I can get better. I have 2 tips for you. One is search for YouTube Erichto how to start. So this thing, watch that. Maybe you have done this already. And second is read the Competitive Programmer's Handbook, at least the first chapters, which is possibly mentioned in the video. I'm not sure if that's the case. So this is the video, and oh yeah, it links here the book. So there is a free PDF where you should at least read the first few chapters. Legacy problem from Codeforces. Is it the one about portals? Yeah, it's a nice problem. I taught it multiple times during some camps. Maybe one of them was recorded and published to YouTube. I don't remember. But I agree, it's a nice problem. In particular, it's possible to do in single logarithm and where there are portals from range to range. So some hard follow-ups. And there are multiple solutions. Yeah, you're welcome. Togot shoes. So what, now we should continue with the contest from yesterday. I saw a mention of C and D. And now regarding this, so to finish with this problem, I think I would enjoy solving this problem in a contest. I'm not sure if it's a good problem to be covered during a stream, because the statement is so complicated that you need more than 1 minute to explain it. And if somebody is joining a stream, they will have basically no chance of following along quickly. I'm from Poland. Future of CP, I don't know. Online competitions will not matter too much. Yeah, Tahasin. Maybe one day I will cover legacy. I will. Okay, skip. Let's see what this is. Subset multiplication. The kind of division 1A problem. Alice has an array with n positive integers. AI divides AI plus 1. So most of the numbers will be equal to each other, and sometimes there is an increase. Already, without reading the rest of the statement, I can tell you that this might be important property. Because if you have a sequence where every next number is a multiple of the previous one, maybe with equalities, then every time when there is an increase, it increases at least twice. So there will be at most logarithmic number of increases. So, and other than that, it will be sequences or ranges, blocks of equal values. So property of something like that will be, you will have at most logarithmic number of blocks of equal values, and between them big increases. Of course, during a contest, you shouldn't stop and make such observations just after the first paragraph. You should know the full problem. But I'm already betting that this will be important. Bob sees the beautiful array and is jealous. To sabotage, he creates array of size n, so the same one, bi equals ai. Then he chooses a positive integer x and multiplies some elements by x. So some elements he multiplies by the same value x. You're given an array B, you don't know array A and the chosen number x. Please output any integer x that Bob could choose. So that multiplying some subset elements and so on. Okay, you're given an array elements that is not necessarily of that property, that every next is multiplication of the previous one. And you need to multiply some, no, you need to divide some elements back by x to get back to the property. Well, either this is already a good array, or you can see at least one one not satisfied property where there is no divisibility. And here you will have limited number of candidates of how we divide the previous number so that there would be, this sequence would be good. That's one possibility. The other, I'm tempted to say that we should do it greedily. Going maybe from left to right seems stupid because this is good, and then you look at that and you cannot drop it because this is 42 already. Maybe we should go from right to left, and every following number drop just a little bit if needed. So going from the end, let's say at the end I see a number of 100. Before that I see 50. This is okay. But before that I see 70. 70 versus 50 is not good. So I should divide. 70 I want to divide by 7. So 10, now 50, 100. I divide by x equals 7. I can modify the future, but then let's say I see 10. I see then here, let's say 140. This will not work, but 140. If I divide it by 7, it's not enough to fix. I need to divide at least by 14. But that means retroactively I need to do some modifications on the right. I spent 90 minutes on the first problem just to realize that my solution that I made in 5 minutes was correct. That happens. Yeah, so that's my idea. Iterate backwards and keep expanding this number x that you divide by. When you see that something is bad, you need to increase x to something bigger. And this will happen again only logarithmic number of times, because every time I change x into its multiple, I can go decreasingly again from the right, and this time use this value of x. And I greedily apply the division if it's needed. We're multiplying. The Bob multiplied. The task here, I think, is that we are given a sequence that is already multiplied, some elements are, and we need to divide it back. And for such a problem, especially because it's relatively easy, if you look at the full contest, right? Among the, how many, 8, 9 problems, it is the third one. Usually, ideas that I have initially, like intuitively, work. So I'm not going to analyze this further. This is not, also during a contest, I would by now code it. I'm going to read the values. X is initially 1, and while true, iterate from n-2 down to 0. If AI, what do we output? We output the value of x. If AI plus 1 modulo AI is not 0, then AI plus 1, sorry, AI, I want to divide by x. Unless it's not divisible. If AI modulo x is not 0, then this is game over, I think. Assert false. I think that shouldn't happen. If I see runtime error, I know that this piece of my logic is incorrect. Otherwise, we divide by x. And if still this is not the case, then I need to divide AI some more. But by what? And this will not happen too many times, as this increases the value of x. Also, every time I want to restart A. So every time I remember the initial sequence, and every time I start from that initial sequence. Now, if this is still something, then I will do stuff. Finally, if I equals 0, then output the current x and return. What do we do here? We see, for example, that there is 70 and after that 50. I need to divide this by something extra, by a divisor of this, of AI, that is not a divisor of 50. So I think we will here iterate like that. If AI modulo D is 0, and A of I plus 1 modulo D is not 0, then multiply x by that, well, and break. Finally, it's possible that I don't find anything, because here I only find divisors that are not equal to AI. Maybe I need to consider AI over D. Finally, if not done, assert, not assert. I want to do this. And just break down. That. I hope that this will not overflow, but if I don't have mistakes, it cannot overflow. And do I need to consider other divisors, like those of form AI over D? I think that always here we will multiply by some prime, and primes will be found this way. Well, let's check what happens. Does it even work for the samples? Assertion failed. Also, in the first task we print 1. Well, that is correct. In the second we print 512. That's very suspicious. How many zeros are here? This is 500 million. This is 1 billion. Why do we go up to 512? I divide by GCD of 2 consecutive values? I don't know, maybe. Just remember that I do not want its time limit exceeded. Why? I claim that what I typed is O of log of values multiplied by n. This is how many times I can iterate. And also every such iteration might end with square root of AI. Unless there are multiple test cases, each of them has a small n, and I try to factorize something. Oh, that I think kills me. I focused on solving a single test case fast enough, but there can be multiple test cases, each with a huge value. So I cannot do it this way. I need to be smarter about it. So I need to find now I understand the comment or hint from earlier, and I'm not happy about it. So again, please do not give me hints while I solve problems. Yeah, I need to, like for those values 70, 50, I need to find some part of this, of the 70, that is not inside of 50. The common part is GCD, so 10. And if I divide this by GCD, I will have what is left. So common is GCD of AI plus 1. And if I divide like that, this is the extra value I need in X. Also, the code is shorter. Let's see what happens. 1, 2 to 6. I don't know. You don't get penalties for incorrect submissions on the first test. And the values seem reasonable. Oh, and now this comment is obviously incorrect. It's n plus, I think, log from GCD. That's a big runtime. Is it because of reading the int? No, not really. Interesting. Do you think problems have become tougher to avoid cheating during contests? No. But they became a little bit stranger to maybe avoid cheating. Yeah. Can you do B from yesterday? I think I will move to D. So I will move to harder problems, not easier. I try every second stream to do division 1, so harder problems, and like yesterday on Sunday I did easier problems. So yesterday I would do B. One more thing, I want to look at the standings, open some submissions in the top and see the runtime, because I'm curious if my 1 second is unusual. $200. Okay, I overcomplicated, right? Oh, we don't need to go again and again. I see. So I have the unnecessary logarithm. What I did is, every time I go backwards, I have some current candidate for X, and if it doesn't work, I modify it. Instead, you could just once go from right to left. This is the bad thing. Okay, so you see how much AI needs to be divided by how much it needs to be divided, and then you update answer accordingly. You increase answer up to this value. So for example, if you see that you look at AI plus 1, and you see, oh, AI needs to be divided by 14, at least by that. And if you see that answer is at already 4, but, sorry, answer, the x value, but you know that you need to be able to divide by 14, so this needs to increase to something that is also divisible by 7. So you modify this up to, well, 28. And the exact logic of this, I think, is this line, where the answer gets multiplied by h, divided by GCD of them. So 14 times 4, but there is a 2 in common, so divide by that. Okay. Makes sense. I overcomplicated the solution, though. After one incorrect attempt, at least in my head, also there was some logical mistake, sorry, implementation mistake, because I printed 512. Yes, that's least common multiple. I confirm. Okay, let's move on. Next will be problem D. Make a palindrome. I'm not sure if I like it. Yes, Euclidean algorithm is how you do GCD. But you don't need to think about it if you have a function. Anikite, that's a nice way to put it. LCM of all required x. That works. Though it's not trivial that it works. That's modifying x at one position doesn't mess it up for the other. Okay, D. You're given an array and an integer. What you can do is select a range of size at least k, select an index within that range, smallest number out of the subarray, then delete it. Check if you can get a palindrome. So the statement is, you are given an array and an integer k. Maybe given a of, well, 1 to n and integer k. You can repeatedly choose any range and remove kth smallest value. So that kth smallest needs to exist, so the range needs to be of size at least k. And the question is, can we obtain palindrome array? Well, if k is 1, we can do whatever we want. Why a palindrome? How does it matter? Very small values will remain, it seems. Also, at the end, you will have at least k minus 1 values. So in particular, k minus 1 values, smallest ones in the full array, they need to remain, so they will be part of the palindrome. It seems that everything else you can as well erase. So my observations are, the k minus 1 smallest values will remain. Values tied to k minus first smallest might remain, because this is not very well defined. Values greater than k minus first smallest, I think we can as well erase, because they might help us create a palindrome, but their positions need to be symmetrical, and if we remove them, then what remains also is symmetrical. So I think those we can just erase. So make a copy of the array, sort it. This way you find the k minus first smallest value. Everything that is strictly greater than it, erase. The values smaller than that, compared to each other, they need to be symmetrical. And now you have some values equal to the k minus first smallest. And among them, you can remove some of them. You want at least k minus 1 to remain, and you want the remaining sequence to be symmetrical. I can't understand kth smallest number. To solve this problem, if you say you cannot understand this definition, then this is not a problem you should attempt. Okay. So there is a sequence. First step, erase the bigger values. Then you have some values smaller than that k minus first smallest. Maybe they will look like this: 2, 3, 2, 3. If you see this situation, you can immediately stop, because they are not symmetrical compared to each other. They do not create a palindrome sequence. If they are like this, then there is hope. Now, remaining values are all tied to that k minus first smallest. Let's mark it as x. You want to remove some of them. And I think it's quite, you can erase any one of them. You just choose a range containing it and you say this is the kth smallest. I wonder if it ever makes sense to choose bigger ranges. I think in my logic, in my head, I always choose a range of size exactly k, and I just choose I erase the maximum value there. Yeah, not sure, but my guess, my intuition is that it's good enough. Didn't know that C++ multiset doesn't have log order statistics. Yep, it doesn't. So what we need to obtain here? Well, we have those smaller values that need to remain. So in this case, between 2 and 3, nothing is there. So those elements we would need to erase. If there were extra x's here, those we need to erase. So I look at what happens between every 2 consecutive small values, and I need to make this sequence of counts or block sizes symmetrical. And this way I will get to know how many numbers will remain, and I check if at least k minus 1 values remain. I think that's it. So solution. Let x be k or kth or k minus first. I think it doesn't matter. K minus first. What if k is 1? Let's say kth, and the logic will be that in particular we can erase all the values equal to it. Kth smallest value in the sequence. Erase all values greater than x. Find values, or maybe collect values smaller than x and check if they make a palindrome sequence. If not, stop. What remains is count values equal to x between the values smaller than x and make that count sequence palindrome by removing some values equal to x. Check if at least if the number of remaining elements is at least k minus 1. I'm not sure if this is a correct solution, but it looks like a solution. Sometimes that's good enough. I'm making a copy of the sequence. I will read the smallest element there. So position k minus 1. In the A sequence, I'm going to erase all the values greater than it. So make temporary vector for every element in X if it's smaller or equal than every element in A. If it's not greater than X, then push to the new thing, overwrite, and don't use n. This is a trick that you can do if you are not going to use a variable from now on. If by mistake I use this variable, for example, I print n, I will get a compilation error saying variable don't use n does not exist, because I overwritten the definition of a command n. Because from now on the n is not up to date. Of course, what I could do is this, but it's also a little bit dangerous because n is different from the initial value. So instead, I'm going to say, I think I'm not needing n from now on. If I do, I will think about it. Very new problems do not have difficulty assigned. Okay, now what was next? Collect equal values. No, smaller. If smaller than x, then equal push back this element, and check if equal is a palindrome. For example, reverse equal is not equal to, return false. Let's say that my test case function will return yes or no, and I will print the answer here. Okay, additionally, I want to count values equal to x between of them. So blocks or sizes. If element equals x, then the most recent block plus plus. If smaller, then blocks push back block, and the block becomes 0. And at the very end, I think blocks push back block. So in particular, we have stuff before the first element and after the last element. If there are no values smaller than x, there will be a single 0 here. No, a single value this. Okay, so this way in blocks I counted between small elements how many elements equal to x there are. For example, it might look like this. So let's say there are 3 values of x, then something small, 2 values of x, something small, single x, this, a lot of x's, this, a lot of x's. Then I count blocks is 3, then 2, then 1, then 4, then 5. And now this sequence I want to be palindromic as well. So those two values need to be equal. Those two values need to be equal, and so on. So let's maybe count how many I want to erase. Erase plus equal the difference of blocks of I minus blocks of this, the opposite ones. So first with last, second with second last, and so on. This is how many you erase. You also erased stuff that is greater. Yes, I think so. Now I think that maybe we shouldn't have done that. If this, else erase plus plus. And now I need to check if the original value of n, so actually I'm going to use it, if n minus erase, this is how many numbers remain, if there are at least that many of them. And we return yes or no. I don't think this will be fully correct. Too many guesses. Well, the sample worked. So that's something. I'm streaming in adventure game category. Really? I am not. I feel bamboozled. Okay, accepted. Okay, so I'm happy that I had good intuition and good guesses, but it would be hard for me to maybe really thoroughly explain all the steps of this intuition. I will not solve CSCS problems today. My approach was iterate over the array from start to end, from start and end. If we find mismatched pair, erase the larger one. If we have at least k elements than that, we find mismatched pair, erase the larger one. I don't know why, Suraj, what you described works. Yeah. Okay, sorry, I wanted to show this. I opened the link with PNG. What? Twitch decided that I'm streaming a game of education? What is this? Having done some terrible things in his youth at school, do something. So it's some kind of video game. And Twitch automatically understood that I'm streaming that. Why is this education? So stupid. So I chose some category here. What people do, what they use for coding? Those are, I think there is no category here, right? It seems it's also incorrectly assigned. Well, software and development, can I choose that? Okay, software and game development, I think, is what we want. Okay, good. Man, timeout. Recurring villain of the stream. In some, I don't know, TV series about superheroes, stuff like that, cartoons, movies, you will wonder why the superhero will fight the same enemy again and again instead of just killing them or something, and instead they just put them in jail and they escape. So maybe I'm doing kind of the same thing with this guy. Instead of banning him already twice, I have put him in timeout for stupid comments and repeating stuff. I seem weaker physically. What happened? I'm not sure I was ever in better shape, at least in the past 5 years, than I am now. So maybe it's this t-shirt. I started CP around 15, but I did math for many years earlier. So what? How long is the stream already? Hour 20 minutes. I think we can try this one. At least I want to read. We'll see if I want to solve it. By the way, is the zoom in Codeforces enough for everybody? I have it at 125%. Sometimes I do it like that, 150%. Is it significantly better for anybody here if I do this? I don't know how much of full screen you're using when watching me. So for me, it's anyway huge. I could put it down to like 70% and I would see everything. 150 better. Okay. I will keep at 150. 2 people quickly said that it's better. So. Make it 0. You're given an array A. You can do the following operation. Codeforces is so much about those operations, and I understand that this is how you can create a lot of problems, but also it's then never a beautiful statement. Actually, I don't like this about AddCoder either. They have short statements, but so many times it is you're given a string or sequence and you can do operations. Like count the number of possible target sequences. I don't know. You need 130 IQ to reach specialists? Maybe. Yeah, you need to practice, and maybe you will get there. Select an array B of same size, such that every element is limited by the element from A. So the given array is limits. There exists an index such that prefix equals suffix. Then subtract BI from AI. Oh. So you need to decrease the array A. Every element decreases a little bit. And there needs to be prefix and suffix such that you decrease by the same amount. It's possible in at most 17 operations. So they needed to specify that so that we wouldn't have doubts about the output size. So in every operation, we decrease some AI values. There needs to be prefix with sum of decrements or decreases equal to the sum of in the remaining suffix. What is the proper word here in English? Is it decrements, decreases? What word should be used here? What if a of 1 is equal to something big and everything else is 1? In particular, what if this is the case? I think I misunderstood the statement. I don't see how to do it first, this sequence. Oh, there can be, the answer can be -1. Okay, got it. In particular, if there is value greater than everything else, or everything after that, this seems impossible. I think we can kind of think about it as matching, where let's say that the values are 3, 7, 5. The 3 from here will be matched with 3 from here. No, not exactly. This has bad parity. Let's go with this. It seems that maybe I want to visualize such a test. If I have a sequence of 3, 7, 6, I would think about it like this. We have 3 tokens or boxes, balls in the first place, first index, then 7, then 6, and we do a matching that looks like this in this case. Now I combine things into pairs. Why is that? Because every time when I decrease by some stuff such that prefix equals suffix, there is this middle point and everything on the left is equal to stuff on the right, so I can combine this into pairs. So I think the answer is the solution is possible if and only if we can do such a matching. So it boils down to the sum of values is even and the greatest value is not greater than the sum of everything else. I think that's enough to check. In particular, this is even, this is even, this is odd, and additionally this is greater than that. So samples are weak. I think this should be broken into 2 separate test cases, one where both values are even but one is greater than the other, and separate where it's about the parity, so like n equals 3 and the parity doesn't match. I reached top 200 in leaderboard. Impressive. Now minimum number of operations. I wouldn't be surprised if the S value is actually at most 2. So here we need to do the split by this position and by this one. And isn't that enough? Shouldn't I? If this task, if it wasn't E, if it wasn't letter E, if instead it was like division to C, then I would already start coding, thinking that what we need to do is we need to find what prefix of this sequence is enough to reach half of the sum of all values. And then we will do one split here and one split here. So the sum of this prefix will be matched with some stuff from here and the suffix. And there also needs to be split here so that this remaining part will be matched with something on the right. Apparently it's not that simple. Unless, let's look at standings, if maybe some people solved it in 5 minutes. No. Tourist 10 minutes, so it needs to be harder. Answer is equal to 1 only if there is exact split of prefix equal to suffix. Do you believe E is easier than D? Well, if my idea is correct, then yes. But I don't believe that my idea is correct. "17 so heavily suggests logarithm of n." Also, n is up to 50,000. They wouldn't use 50,000 if the solution was that simple. Here I came up with trivial linear solution. There must be something else to it. So med, I think that the answer is -1 if the sum is odd or there is a value greater than the sum of everything else. Cute dog. I agree. So can somebody give me a counterexample to what I'm saying? I'm at 80% sure, let's say, that it must be incorrect because it would be too simple. My solution is find the split of the input sequence into 2 equal parts, prefix with suffix and suffix with same sum, and then just split once to the left of that value and once to the right of that value. And the answer is 1 or 2, depending on whether there was a perfect split. Do I like thinking? Yes, I think it's very correlated to living. And yes, I part-time work at Huawei. It's a small B2B cooperation. It's not even half-time or anything like that. My question was more to somebody who can analyze what I said. I think I want to read the first sentence of the editorial or something like that. So hint 0. Solve the n equals 3 case first. I think I know how to solve it. With 2 operations at most. My observation seems wrong. Can you give me a counterexample? Or explain why it's wrong? Showing the dog, part of it. It was correct. The answer, I mean, at least this part. The answer is -1, 1 or 2. So, was my solution correct? Okay, this means that what I said is incorrect. Find the construction in 3 moves, then optimize to 2 moves. 5, 3, 2. Well, for 5, 3, 2, there is a perfect split. And in such a case, I would just split like that, and I would say decrease by 5 here and by 3, 2 here. My dog has a bowl of water in the kitchen, but he so much likes fresh water from the shower, and sometimes he will just come to the bathroom door and whine that he wants to get there, and what he actually wants is water from the shower. But what I said immediately gives me 2 moves. I don't have this. Okay, I'm going to code it, but I'm so confused. What I half expect is wrong answer on test 2. Come and visit India. I was there twice, I think. Why is n so small? Such a strange problem. If sum is odd or big is greater than everything else, print -1. I don't play much chess. The split logic? Well, I want to split the sequence into equal prefix and suffix. So now, for every element, increase by this much. Now, if prefix times 2 equals the sum exactly, we have a perfect split, and we will be able to do it with a single operation. What do we output? The values. So just output the sequence. Also, if this is already too much, then I should have just stopped. So there is prefix of 0 to I minus 1, there is suffix of I plus 1 to n minus 1, and the element I will belong partially to one half and partially to the other half. And I need to figure out how much belongs to each half. That depends on the difference between them. So I can say, maybe let's go back, prefix minus equal AI. This is what is on the left. Suffix is sum of everything minus the prefix. So now this is suffix to the right from I, this is prefix to the left of I. And there is some difference between them. Let's make sure that I can do something like this. I will do it by doing what? 3. In order to guarantee that this is equal to that, I first need to match a little bit of the middle with the right part. How much though? What I want is, let's say, prefix plus AI equals suffix. This is what I want to achieve. For that, I can match some part of AI with some part from the suffix, let's say. No, in order to achieve this, I can match those. So initially this is likely greater than suffix, and by assigning 1 unit of here with 1 unit of here, I decrease it by 2. So what I want to match first is the difference of prefix plus AI minus the suffix divided by 2. Because by matching a single pair, I decrease this value by 2. 1 from here, 1 from there. This is how much I want to do. Assert in particular first cannot exceed this, first cannot exceed that. Now I'm going to output that, so for stuff up to the current position, which is I, print minimum of first. Okay. I want to decrease by that much. This is how much I use. So minimum of the value I'm looking at and how much I want to decrease by is what I use. Possibly 0. Also a of, let's use a variable for that. I print that. In the remaining I decrease by it. A of j I decrease by it. Remaining now should be 0. I print first once more, and this is by how much I decrease AI itself. For remaining positions, I don't do anything with them right now. I need to output 2 because I will do 2 operations. And now I achieved that. So what I have, or maybe achieved, is prefix plus AI equals suffix. Let me hide the camera. Suffix. So now what we want is just, well, output everything. J. Prefix. I used pref. Remaining versus a of j. Which one is an int? No. Is this enough? 1, 2, 3, -1. Why am I printing so much? What is the input? 1, 2, and 2. Something is wrong with how many test cases I'm solving. If AI is greater than prefix or AI is greater than suffix, answer -1. No, why? Like 2, 5, 3 is solvable. Oh, after this, I need to return. I'm solving the same test case more than once, and sometimes it will be absurd what I'm printing. Okay, 1, 1, then it will be 4, 2, 1, 5, and we will have how much? Okay. What is this theme in Sublime? In Genie, this theme is called Monokai. Genie Monokai theme. Monokai. This one. It's warm, colorful, and pleasing to the eyes. Well, I'm so confused by this problem because I think that it is easier than D. I mean, I would solve it in a contest, I think, easily within 10 minutes. So I'm surprised that people in the top spent 15 minutes. Strange. Of course it happens. Maybe I just got very lucky with my idea. But I spent more time being confused than actually coming up with a solution. And the code is simple. Well, interesting. I think that judging by the number of accepted, the next problem is significantly harder. Also, we are nearing the 2 hours of a stream, so I think we will wrap this up now. Just let it, accepted, good. I particularly like my final explanation for the first problem from today, which was token removing. Codeforces, token removing. So this one, so in some way I will put it on Codeforces, info about what timestamp you can watch it. I think it's significantly better than the editorial one. Please do the stream tomorrow. Let me see. I will keep alternating between Division 2 and 1. I think that the next one I will do on Wednesday, maybe. So Wednesday Division 2 stream. I think that's a good idea. Maybe here. Our blocks. So Wednesday, July 9, and that will be, I wonder if this morning time is good or not. I feel like later is generally better, but I feel productive enough in the morning, so I wonder. Actually, what do you think is the best time? Maybe I will share, I will think out loud, and you can tell me if you see any flaws in that logic or I'm missing something. Best time for streams, question mark. So I live in Poland, and when I do it, today I started in the morning, and that was my 9 a.m. Polish time. This means in Europe it's morning. In, for example, India it's afternoon, just after the noon. More to the east, like Vietnam or something like that, China, it will be afternoon. In the US, it's night. In the US, it's midnight. On the west coast, on the east coast, it's 3 a.m. So this is Europe morning, India noon, Far East. So for example, stuff like Vietnam, roughly in that geographical area, afternoon. I think during summer, when a lot of people will have different schedule, this is fine, but I would guess that during normal months, it's a very bad time because those people will likely be in school or job. So I feel like in weekdays, this is not a very good time. Yeah, starting 8 in the morning is not a big difference. So let's say 8 is equivalent to 9 or 10. Then the alternative is, let's see the alternatives. That's Europe noon, India afternoon, Vietnam, China, stuff like that, but I don't think China watches too much of YouTube or Twitch evening. And it's a beginning of viable time for the US, but not yet. So on the East Coast or some part of Canada, it will be 6 in the morning. At the end of the stream, maybe some people will join. It seems that if people work from the morning to afternoon, this might be a little bit better for maybe somebody in Europe who wants to do it first thing during a day. But on the East, this will be better because you're more likely after the school, university, job. Then what we can also do is this. And that's Europe afternoon. At India, this plus, depending on the summer versus winter, it's either 3 hours and a half difference or 4 hours and a half, but roughly, let's say, it's this. And Vietnam, China, late evening. Then in the US, it will be somewhere between 6 a.m. to 9 a.m. depending on the region. That seems to be superior, right? No, in the second case, India is 3 hours and a half or 4 hours and a half depending on the time of the year. And finally, I'm aware that I could do this, but it has disadvantages to me. But let's say this is Europe evening, India late evening, Vietnam night, US morning noon. I understand how this is convenient to a lot of people. For example, for those it's roughly okay. That being said, it's inconvenient for me a lot for some reasons. So first, sometimes I will have stuff to do around that time, like I will go play volleyball, but also my wife is home and I want to spend some time with her or just seeing friends. So I don't want to do regular streams at that time if possible. Yes, I agree, Don't Master, that this thing in places like Vietnam will be midnight. In China, it will be even later than that. It's at least plus 6 hours. So considering also my schedule, I would say that this time is superior. Yeah, I got married 3 years ago, but thank you. So should we try doing this tomorrow? for me, the argument for the morning is that I'm never tired in the morning, almost never. So I have a lot of energy and will to do something extra. In particular, the stream is never something I need to do, right? In the afternoon, maybe I will be busy or tired after doing other stuff, usually job related, and I might not want to stream, but still, this seems superior. Maybe superior is too strong of a word, but it seems best. So do we have the winner? If so, let's try that tomorrow. Oh, and weekends are different. Yeah. On weekends, but also on weekends I cannot do regular streams because my weekends are not that regular. Okay, so what I think we want to do is 3 p.m. Oh, I know another argument. This is closer to a possible Codeforces contest, but the Codeforces contests are not that common. Yeah, that's fine. Okay, time and date announcer. We are in Warsaw. I am. Tomorrow. Division 2 I usually do for 90 minutes. Oh, I modified something else. Division 2. And what will be next? This is not Wednesday. This. Oh, I cannot do it on Wednesday. Let's go with tomorrow. And I actually chose tomorrow. Then we'll see. So see you tomorrow at 3 p.m. Polish time. And I will try to prioritize this time slot generally for the streams. I will stream more this week. I just don't know yet. I have some stuff on Wednesday and Thursday. I'm not sure about the time. On Friday it depends. Well, we'll see. How big is your monitor? I can barely see the text. Well, I wonder if this matters. So starting from a couple of months ago, I actually have a huge monitor, 32-inch. And it's 1440p. But wait, does that matter in terms of this? Oh yeah, I see, it does matter. Okay, well, I will usually open Codeforces on 150%. But I need to keep in mind that because of that, I need to have the zoom in bigger. Maybe also on Genie, I need to increase the font just a little bit, though this seems already quite big. Hello, Ahmed. Okay, so it's everything. The font seems fine. Good. OCOG, I think that almost for every threshold, you need to solve a lot of problems around that difficulty, and in those problems you will see the topics that you encounter. Okay, I will start, I will finish the stream same way I started. So talking about the classes I will have next month. And that's, I think here I will find it. Okay. So this is a work in progress announcement. It's not posted yet. I will do dynamic programming classes in August. Twice, it will be twice a week, and it will be in the morning Polish time, I think. So I will think about it. One group will be solving easy DP problems. So if you know already how to do something very simple like computing n Fibonacci number, but generally you struggle with DP, this will be a class for you. In particular, we will solve a lot of even new original problems, variations of knapsack, problems with 2 or 3 dimensions, so you would get efficient with that. A lot of solving problems. And then second group, for more advanced competitors, will be about harder techniques and not that many problems to solve, like DP optimizations, divide and conquer, KNUF, maybe some hard variation of digit DP, broken profile, mention of some over subset, knapsack without one is one nice technique, some inequalities with digits, switching dimension versus the answer. Sometimes answer needs to be part of a dimension. I think stuff like that. So, and the price I think will be around 250 euro for 1 month, 8 classes, because it's twice a week. The registration is not started, but so every day, every stream, for me, this announcement evolves a little bit. Only yesterday/today in the morning, I decided what exactly will be the topic of those 2 groups. And I will do Sunday lead code classes. Make a great website and upload your content there. I think that YouTube and Codeforces is good enough. No. Okay, so the stream is ending now. If you have thoughts about this, you can write to me, for example, via Codeforces. In particular, if you want to join, you can write to me already. And if so, you can have a little bit of influence on what will be those groups exactly in the time. So if you think you will join, again, the price around 250 euro, and the classes will be in August. Then write to me and tell me like what you want to be covered and which group you're interested in. Okay, so the stream is over. Thank you everybody for attending. We solved the CDE problems from yesterday's division 1+2 and that one token removing problem from before. I think it was a nice educational stream. Just the last problem was strange because it was surprisingly easy. The make it 0. It was trivial to me. Well, okay, have a good day, everybody. See you tomorrow at 3 p.m. Polish time. Bye-bye.